Hi everyone, this is our second lesson for the topic numbers of any magnitude, and in this lesson we're going to look at units of measurement. So far this topic we've looked at estimating and rounding and significant figures. There are 7 units that make up the international system of units. For length, the standard unit is a metre, and you can still go to Paris and see one of the original metres that was constructed back in 1791. For mass, the standard unit is a kilogram, and for time, it's a second. Now the next 4 we're not really going to cover in this topic, but they are electric current, which is the ampere, temperature, which is the Kelvin, not Celsius, intensity of light, which is the candela, and the amount of a substance, which is the mole. Now you might cover some of those in science. Now we can define smaller or larger units than the standard by using any of these prefixes. Some of these you'll be familiar with, like milli, millimetre is 1,000th of a metre. Kilo, kilogram is 1,000 grams. You would also have come across mega, as in megabytes, and that's millions, and probably gigabytes as well, that's billions. We also commonly use micro, which is 1/1,000,000th, and nano, which is 1/1,000,000th, and they all have symbols as well. We also accept centi, which is 100th, like centimetre, it's 100th of a metre, and deci, that's not commonly used in Australia. So when we're making conversions, we firstly have to find the conversion factor, and then we either multiply or we divide. Now this remains a concept that's quite tricky for many students. You do get better at it over time, but here's a simple way of remembering it. We multiply if we're going from bigger units to smaller units because we want more of them. So if we want to go from kilometres, say, which is a bigger unit, to millimetres, which is a smaller unit, we want lots of these, and multiplying is one way to get that. We divide if we're going the other way, if we're going from smaller units to bigger units because we want less of them. Here's another thing that I teach my students. Almost everything in measurement conversions is 1,000, except for centimetres. If you think about it, there are 1,000 millilitres in a litre, 1,000 grams in a kilogram, and there's 1,000 millimetres in a metre. What stuffs all of that up is centimetres being stuck in the middle. There are 10 millimetres in a centimetre and 100 centimetres in a metre. Now, this isn't always true. Time is a common example of when it's not 1,000, but it almost always works with metric. Here's a couple of examples. Convert 12 kilometres to centimetres. So we're going to have to go via metres. Okay, so firstly, convert 12 kilometres into metres. There are 1,000 metres in a kilometre. We're going from bigger units, kilometres are bigger than metres, to smaller units. So we need to multiply. 12 times 1,000 is 12,000. Now we need to go to centimetres, which are even smaller. So I'm going to multiply again. And there are 100 centimetres in a metre, so times 100 gives me 1,200,000 centimetres. How about this one? 12,000 micrograms to grams. Firstly, we need to know that there are 1,000,000 micrograms in a gram. They're smaller things. So we're going from smaller things to bigger things. I need to divide. I'm going to get less of them. So I'm going to do 12,000 divided by 1,000,000, which is going to give me 0.012 micrograms. A relatively new measurement system is data storage, but you're probably quite familiar with it. Now, 1 kilobyte of data is actually equal to 1,024 bytes if we are using the binary number system, which is base 2, and computers do use that number system. But fortunately for us, data storage now follows the metric system. So we have a kilobyte is 1,000 bytes, a megabyte is 1,000 kilobytes, a gigabyte is 1,000 megabytes, and a terabyte is 1,000 gigabytes. Most devices these days store data in terabytes, but we're already preparing for petabytes, exabytes, zettabytes, and yottabytes. And in each case, the conversion is 1,000. Here's an example. If a memory card stores 4 gigabytes of information, how many 280 megabyte TV episodes can I store? So we need to make a conversion here because we've got gigabytes and megabytes. Gigabytes is the larger unit, so I'm going to turn this into megabytes. There are 1,000 megabytes in a gigabyte. So in 4 gigabytes, there are 4,000 megabytes. Now we want to know how many 280 megabyte episodes can fit into that. So that's a division question. 4,000 divided by 280 is 14.2. So we can store 14 shows. Now you should be familiar with the standard measures of time. They are second, minute, hour, week, fortnight, month, year, decade, and century. I'm not going to go through these conversions because they are second nature to most students, even though they're not decimal. But for small measures of time, we commonly use millisecond, which is 1,000th of a second, microsecond, which is 1,000,000th of a second, and nanosecond, which is 1,000,000,000th of a second. In terms of large measures of time, we have a millennium, which is 1,000 years, a mega year, which is 1,000,000 years. We also have a galactic year, which is the number of years for the solar system to orbit around the Milky Way. Well, it's 230 million years. And we've also got a giga year, which is 1,000,000,000 years. Here's an example. The distance from the Sun to the Earth is 151.47 million kilometers. The speed of light is 300 million meters per second. How long does it take light to reach the Earth? Now this is a distance, speed, time question, so I like to use the DST triangle. We want to know how long does it take, so that's time. And time is going to be distance divided by speed. But we've got an added complication. We have different units. We've got kilometers here and meters here. So we need to do some conversions. Firstly, distance is 151,470,000 kilometers. And our speed is 300 million meters per second. We need to convert this into kilometers, and there are 1,000 meters in a kilometer. We're going to bigger units. We want less of them. Let's divide. So that's going to be 300,000 kilometers per second. Now we're ready for our division. It's going to be distance divided speed. So this number here divided by this number, which gives us 504.9 seconds. It's a bit ugly. Let's turn it into minutes. So we're going to divide by 60, and that gives us approximately 8.4 minutes. All right, that's it for this lesson. Our next lesson, we're going to look at error in measurement.